Test, test.
Okay, so as I told you before, we will have our next presentation. It's about Lunarpunk. We have Rose here. Let's give her a warm welcome.
Thanks. Can you guys hear me okay? The mic's correctly? Okay. Can I ask how many people here have heard the word Lunarpunk before? Okay, so that's... I think it's off. Oh! Okay. Off again. Oh, it's the cable? Okay. Yeah, no, that's fine. Whoops. Sorry for the delay. All right. Okay. I'm just going to put the phone there, so that's for the notes. Okay, so most of you guys have heard about Lunarpunk. I'm not actually going to spend all that long on it today, but because I only have 20 minutes, and I'm actually going to talk mostly about DarkFi on the technical level, and try to convey to you guys how it is that DarkFi achieves general anonymous programmability. In terms of Lunarpunk, though, I will just give a quick introduction for those who don't know, and also as we're at a Solarpunk conference, I think it's important to reflect a bit on, like why that was proposed. So Lunarpunk was brought up by us in an article that I wrote for eGirl Capital back in 2021, and then Rect News made a video of the article. And I will kind of rehash the core thesis that was presented in that video, which is essentially a macroeconomic thesis for why we at DarkFi think that anonymous technology is going to grow within crypto. But I just want to say that I feel like that a lot of how Lunarpunk was presented originally has been misunderstood. It has been misconstrued as the antithesis of solarpunk, the kind of negative or the anti-solarpunk. I think that's a misunderstanding of what Lunarpunk is. It's rather should be seen more like a synthesis that combines elements of both solarpunk and cypherpunk. So essentially what it's doing is combining the affirmative kind of future building tendencies of solarpunk with the tactics of cypherpunk. And it kind of, it contains a critique of both fields, but like tries to resolve the problems of both. So solarpunk, it has this nice affirmative energy, but it also, has been twisted by the narrative of transparency, especially in crypto, which is also used, it creates inherent fragility in the crypto space, and, is a kind of infiltration of surveillance into crypto. So, we move away from that into anonymity, but we're not purely cypherpunk in the sense that, cypherpunk has had issues as a movement to grow because it's based on like a negative conception of freedom. And it's essentially reactionary. I gave an entire talk on this at the Web3 Privacy Summit a couple of days ago. So if you're interested in going deeper into that line of reasoning, I would encourage you to check out that talk, which is available on the Web3 Privacy Summit website. But for now, let's get into it. So this talk has 3 parts. In the first part, I will rehash the basic macro thesis that we presented in the Rect video, which is explaining why we believe anonymity is going to grow. Then, I will, in the second section, reflect a little bit on where, this process, what I see as like a process of exit from the surveillance paradigm is leading us toward. So I'll speak like very briefly on the kind of the overarching vision at work, but I won't spend very long on that because I only have 20 minutes today. I'm already 7 minutes in. So it will be a quick note. And finally, I hope to spend most of the presentation talking about DarkFi itself. And again, trying to explain to you guys how we achieve programmable anonymous smart contracts. So, surveillance and anonymity are in feedback with each other. This is part of like why we think that anonymity is going to grow. The more sophisticated surveillance techniques become, the more anonymity must adapt in order to bypass this. So anyone who's worked in cryptography will be familiar that the game of inventing new cryptographic primitives to bypass surveillance is a kind of a cat and mouse game. And we're constantly breaking crypto algorithms, we're constantly evolving better ones. So there's this mutual co-development of these two distinct spheres, which is being accelerated now with the onset of AI. And these are essentially, I see them as forces within crypto that are kind of bending the cryptocurrency space in a certain direction. So on the side of surveillance, we have what we call RegFi, which is crypto as it adapts to like the increasingly stringent requirements of the surveillance state, and it's basically the anti-crypto, the self-destruction of crypto. DarkFi then, is based on freedom and anonymity. And that's what we see as the true promise of crypto, anti-fragile, parallel infrastructure. And, in terms of forces, like these forces that is compelling the evolution of the crypto space into two directions, surveillance is fundamentally about control, whereas anonymity is a technology in service of freedom. So, this is just a diagram which explains the concept of anti-fragility, which was proposed by Nicola Tayeb in his book. Essentially, crypto today exists on a spectrum of fragile and anti-fragile. Transparent systems are inherently fragile, which means that if the external environment turns hostile to crypto, they will see a mass exodus of users and values. So this is the situation that DarkFi is essentially preparing for. When we talk about building anti-fragile systems, we're talking about systems that will actually benefit from increased scrutiny and increased regulatory pressure. So I'm going to speed through this, but I just wanted to note that in these convexity curves illustrated by Tayeb, there's a non-linear relation between the x and the y-axis, which is closer to, an exponential curve. So I just want to say that, we're not actually proposing that over time, anonymous networks will acquire more users, in a linear way. We're actually proposing something bigger and, like a more extreme convex curve. So, I talk about Jay Stark. We're here in the Institute of Crypto Anarchy, where he actually gave his final speech before he was assassinated. And so this is a quote from Jay Stark, which I feel like gets closer to the kind of dynamic that we're looking for when we talk about this anti-fragility convex curve. So Jay Stark says, if something unfortunate happens to one individual, another individual will take his place. It's a hydra you cannot completely kill. You cut off one head, another pops off. We are impossible to stop. So this dynamic, as I said, it gets a little bit closer to what we're looking for in anti-fragility, which also connects to this, what a friend described to me as the law of insurgency. So it's like an insurgency takes place, a revolutionary is killed, and rather than that suppressing the movement entirely, it actually galvanizes a whole new wave. So then 20 more revolutionaries show up to take her place. So that's a really interesting dynamic. It's one that's very, kind of descriptive of anti-fragility. And it's something that we've seen emerging in crypto in terms of for example, the behavior of the community, the crypto community, around the persecution of Tornado Cash, where, instead of the regulatory action, completely blocking access to Tornado Cash, it actually invigorated the privacy narrative within crypto. So that's a trend that we've been kind of aware of for some time. Again, I'm gonna try and be quick with this, but this is an equation that better expresses the anti-fragile relation. This is Metcalfe's law, which is often used to value crypto networks. So in the original thesis on Lunarpunk that was put out on eGirl Capital, we proposed a version of Metcalfe's law, which we could call J. Stark's law, which is inspired by the ethics of free software. Free software puts user empowerment and system anti-fragility in positive feedback with each other, where the more empowered your user base, the more anti-fragile your network becomes. So if you apply this to a real life scenario, say in crypto, we have this divergence where like crypto is being forced to, at least in Europe, implement KYC at the base layer, and there'll be no you'll have to dox every transaction, etc. When this is enforced, we expect transparent systems to see these like mass exits, in this like feedback loop, this like worsening crisis of people exiting. Whereas anonymous networks, they have the opposite dynamic, where attacks actually vindicate anonymity. They drive more users and more value into it. There's something that I call the regulation trap, which is that the harsher these anonymity software is treated, the more it's actually vindicated. So you're actually, in a weird way, giving power over to those anonymous networks and their narratives when you try to force them to stop. So what I just described in a very quick way, which was again a rehash of a thesis that we presented back in 2021, for me, it's explaining like a process of exit, or like it's proposing some possible feedback loops that could lead to this kind of decoupling of the anonymous side of crypto, what we call DarkFi, from this regulated sphere, and also from the surveillance apparatus more broadly. However, it's note that it's not sufficient simply to exit from the surveillance paradigm. Again, we found ourselves within the kind of cypherpunk issue of not having a positive conception of freedom that we're promoting. So it's not enough to simply define the anonymous worlds as a negative, as like a non-surveillance, but actually we need to have a positive affirmative vision that is like the future that we're driving towards. So Lunarpunk is trying to do this. It's using science fiction as a way to generate possible worlds beyond the surveillance state. I see that as the reforesting of society and the regeneration of society by decoupling from the desert of surveillance that is like homogenizing it. So the critical thing here is the use of the moon as a symbol. So the moon it has its own cycles, the cycles of death and rebirth, where it crosses to the underworld and returns. So really, in terms of mythic history, the moon is a symbol of becoming. So I see it as this, as the kind of beacon for this process of regeneration beyond the surveillance state. But also, it's something that I see as like radically exterior. So the moon, again, as a symbol, it has this this meaning of being something that is like something radically different or alien, that is, dramatically beyond our frame of reference. And I think through this process of decoupling from the surveillance state, it's a contact with an alien outside that is a transformative contact, which is reconfiguring the horizon of the possible. The quick version, but again, for the full kind of explanation on that, I really encourage you to see the talk that I gave to the day at the Web3 Privacy Summit. So for that reason, anonymous engineering, which is a kind of core technical concept within DarkFi, I see kind of xenotechnics, which means alien techniques. It's like this this new set of alien tools that have emerged from the outside. You could equally call it lunar techniques. And you know, they're these radically exterior, and they're reconfiguring the horizons of what's possible, which is also why we say that DarkFi is an L1 for anonymous engineering. So, you know, finally we get to the DarkFi part of the presentation. What's important to note is, okay, so anonymous engineering is a new field of engineering that we are conceptualizing. And basically what that means is we're providing a interface for developers that they can use in order to compose anonymous applications. So that toolkit that we're exposing, it includes zero-knowledge cryptography, but it's not limited to that. So you know, we try to offer a more generalized toolkit so that developers can build more featureful applications. We're the only project working in this sector that has this strong emphasis on the new design space that we call anonymous engineering. All other projects working in the privacy space are still stuck in the mentality of we're just going to copy paste existing apps that exist on Ethereum and, you know, rebuild them in this anonymous environment. We're actually thinking, what are the new applications that we can build that weren't otherwise possible? And what are the concepts that we need to evolve in order to reason about this new paradigm that we call anonymous engineering, which is basically, you know, building, hacking, engineering in an environment where not all the information is public, so you can't do like public computation on all the values. DarkFi is, you know, a leading project in this sector for that reason, and also for several other reasons. For one, it has generalizable, programmable smart contracts working now on testnet, not theoretical. It uses anonymous proof of stake, which protects validators from censorship. So, you know, the OFAC sanctioning that happened on ETH would not happen on DarkFi. It has network level anonymity via Tor or NIM, where one of the only projects that's really emphasizing that network anonymity. And was it? Yep, and finally, no trusted setup. So we use Halo 2, which is a ZK algorithm that doesn't require a trusted setup or a signing ceremony. All other projects that I'm aware of had that, and our communities do not tolerate it. So the current status of DarkFi is a alpha testnet. It's our first testnet. And on there we have running the anonymous proof of stake that I mentioned, and a general purpose smart contract architecture that allows us to create and deploy anonymous apps. In terms of the proof of stake, we use an algorithm called Ouroboros Crypsinus, which was first developed by the IOHK research team of Cardano. It's an interesting type of proof of stake because it's not like at all like the proof of stake that you have on Ethereum. So it's actually some of our devs, they call it simulated proof of work, because you're running a lottery locally to your node in which stake, and instead of putting hashing power, you put stake as like the spam deterrent. So that's really nice, and it means that we have anonymous leader selection. So basically, if you complete the lottery locally on your device, then if you like win the lottery, you mint a proof that allows you to redeem a block reward. But we're able to do the distribution without announcing to the network who the block leader is. And the benefit of that is you also avoid DDoS attacks, but it's also a form of censorship resistant staking. So we also have this general purpose smart contract architecture that I will explain more in depth. And we have several apps running on the testnet, including anonymous DAOs, working here now. We have anonymous OTC, atomic swaps between any asset. We have multi-asset anonymous transfers, anonymous staking, and we also have a chat app, which I think I have a slide on, which is, you know, really important piece of censorship-resistant communication for our community and developer team as well. So to kind of hone in on this question of how does DarkFi achieve programmable anonymous engineering, on the DarkFi network, full nodes are both provers and verifiers. So the provers are the ones creating an anonymous transaction. So they have their data, which remains anonymous. They encrypt and basically create this transaction. They broadcast that transaction, that anonymized transaction, to the network. And then the verifiers are constantly searching for these transactions. They get one. They go through a process then of verifying all of the crypto and the various signatures. It's not just ZK. And finally, they do a state transition function, which updates to the new state. Here we're getting into the bit about this programmability. So on DarkFi, transactions can contain an arbitrary number of function call data. So we can basically string these function calls together, and using this create complex on-chain programs. So the call data is data that is defined by the contracts. We will talk about that, the contracts in the next slide. But those, that's arbitrary data defined by the application, essentially. So depending on what you're actually trying to do on the network, there can be variable stuff like ZK proofs, obviously, signatures, commitments, etc. We will expand this toolkit post mainnet, with MPC and other techniques. What we've built now on DarkFi is intentionally simple. It's the kind of most simple, straightforward version of DarkFi that can be, and that's intentional because we want to iterate in a step-by-step way. So MPC will follow post mainnet. So this is a breakdown of the smart contracts on DarkFi and how we achieve that programmability. So there's the ZK layer. We have a ZK VM and an assembly language called ZK-AS, which is a purposefully simple language in order to compose circuits using this VM. So that compiles down to Halo 2, as I mentioned. And what's critical in DarkFi is that we separate the proving from the verification. So, we then combine that ZK layer with this WASM runtime, which the WASM is, gives us access to this SDK where we can import stuff like signatures, elliptic curves, commitments, ZK, etc. And it's inside the WASM aspect where you're actually building the smart contracts that define an app. So there is where the actual computation is occurring, whereas the proving is done in ZK, and then through the VM export binaries which are imported into the WASM contracts. So that's basically how the programmability is achieved. So I briefly mentioned our chat app. We have this contract architecture, we have this proof of stake. We also have a peer-to-peer network, which has been built to be highly modular and very easy to, I'm running up on time, I'm going to wrap up really soon. Very, very easy to plug different apps. So we have these pluggable transports. That's where we get network level anonymity. We already have NIM and Tor support working now, even though we're on testnet. So I think that's the kind of emphasis that crypto projects need to be making on network anonymity. Then, using this peer-to-peer network, we can attach several apps. We have encrypted IRC, which it uses the IRC protocol, but we made our own backend so that we can have encrypted channels, encrypted DMs. It's really cool. I encourage you to check it out. We also have encrypted task management system. A prototype wiki, and we plan to migrate away from GitHub. All of this stuff is necessary for crypto projects to exist in the future. So because it doesn't exist yet, and we desperately need it. So I'm wrapping up here, but in terms of the next step, we're currently in the phase of polishing, stabilizing the current release. We are finalizing the token engineering aspect. So the current, issuance curve, and we're looking into a fee burning. Fees are not fully implemented, so we're kind of finishing that. Once we polish and finish the fee implementation, then we will deploy the next testnet. We will also complete, kind of in parallel, a audit of all aspects of the code base, and then we will deploy the main. So like we're saying internally, like end of year. It really depends on how long the audit takes. But we are trying to get to mainnet as quickly as possible, and many of the decisions we've made is like intentionally to keep DarkFi simple and not to overcommit to too much abstraction early on, but get to the mainnet as quickly as possible and iterate from there. So yeah, that's a short presentation on DarkFi. Check out the website for more information. You can find a link to the docs, which will explain in much more detail what I've just told you. Also follow us on Twitter, and check out our GitHub. Every Monday at 4 p.m. Central European Time, we have a developer meeting on our IRC. So if anyone's interested in contributing technically or just following the discussion, please join our weekly dev chat. Thanks very much.